We have all lived through those times where the best thing about our day used to be playing those retro games. You know what I'm talking about: Super Mario, Contra, Roadrunner, and the likes. 90s kid will especially remember this. And at that point of time, when we used to play these games and when we used to dwell so much into these games, what we at that point thought was, this is just the best thing that has happened to humanity, and there cannot be anything much better than this. And oh, how sweetly we were going to be surprised. The way technology, when it comes, especially comes to graphics, has enhanced, has just blown our minds. From those retro games, things have come to current situation where these high quality games, when we are actually playing those games, it makes us go whoa. So have you ever wondered how these games are created? How these games or graphics evolved from that point where everything was just, very pixely, and to this point where things are looking very realistic, right? Although everything is looking so realistic and so beautiful right now, it's not the end. In fact, it's the beginning of something really, really incredible. That is precisely what we are going to talk about in this video. Stay tuned. So, ray tracing. If you are into technology, or if you are in touch with little bit that is going on in the computer world for the past couple of months, you definitely must have had this word splashed on your face: ray tracing. What actually is it? In order to understand ray tracing in its entirety, it is very essential for you to understand how actually graphics are rendered, especially when it comes to video games today. How do you see those incredible graphics that are presented before you that makes you just lose yourselves into those games? All of that happens with this process called rasterization. So we asked ourselves, what is rasterization? As soon as you start a game, the game code directs the graphics card to produce the scenery and the graphics that the game wants the graphics card to produce in terms of polygons. These polygons are then translated or rasterized on a 2D plane. As soon as these polygons are translated or rasterized on a 2D plane, a shader unit comes in, and it, just like an artist paints a painting, the shader unit comes in and paints the whole scenario. All the shadows, all the textures, all the boundaries, everything that is created in the game is actually created by the shader unit on the 2D plane. This 2D plane that is formed after the shader unit has done its magic is called a frame. And depending on the graphics card and depending on other situations, what kind of game you are playing, what kind of computer you have with you, these frames are produced for a certain number of times in a second, and this term is called FPS. So what is the beauty and what are the problems when it comes to rasterization? Well, we all know what the beauty is, right? Spending hours and hours of gameplay on computer games and wasting your time in general. That's the beauty. What's the con? So when it comes to rasterization, although the amount of frames that are required for a smoother gameplay is something that we have available in our hands, but at the same time, in order to paint the frames the way they are painted via shader units actually takes in quite a lot amount of approximations. So when a lot of approximations are being done, when I am saying approximations, there are a lot of obviously complicated things that are happening in there, but in simple terms, if I want to describe you, the approximation that happen are adjacent pixel approximation, in which the adjacent pixel is created with reference to the real pixel that is being created by shader unit. So there are a lot of approximations that goes on in creating these paintings or frames. So we do not get a frame in a realistic way that we could have. Now here comes the beauty about it. What is it that we can do so that every pixel is presented to us the way it actually is in the game code? This is where ray tracing comes in. Ray tracing, if you pay attention to the word, ray tracing is tracing of rays, isn't it? That means a single ray is being traced from a point. In order to do this, just move with me, alright? Just pick up any point on any object that you see in front of you. The straight line from that point is actually a light ray that is being reflected from the source of light. You understand? Yes. So a light ray is traveling from the source, is striking that object at that particular point, and from that particular point the ray is being traced into my eye, falling on the retina, going through the optic nerve, creating inverted images, and then that is what I'm seeing in front of me. This is the whole process as to how real image in the real world is created inside my head. And people think their iPhones are smart. Anyways, so this is how in real world the ray is being traced. What if this is implemented into the computer world? So what is happening is every single thing will be presented the way it is in the computer scenarios as well. So what will happen as a result of this? Realistic looking graphics and frames, you understand? I'm saying shadows, I'm saying shines, I'm saying bullets flying, and there's shadows of this bullet flying, and there's shadow of those shadows of this bullet flying. These are the realistic things that can actually happen. Is that possible though in real-time graphical applications, especially in games? We are not so sure. Because I want you to understand this, when it comes to implementing ray tracing in movies where these people have huge budgets, huge supercomputers and huge server farms to create those frames, these huge computers actually try to process every single ray that is coming out of every single light source and using these rays to actually create the realistic images that you actually see in those movies. Now when it comes to real-time applications, especially in games, is it possible through the consumer grade hardware that we have to trace every single ray that comes out of every little light source and produce it in real times, when we know for a fact that single frames for some very famous movies actually took around 30 hours to create? We can't do that. So the developers and the graphics designers decided how can we actually implement this so that ray tracing could be implemented in real-time scenarios. Instead of tracing rays from every single light source, what they are doing is they are representing a virtual camera that actually represents our computer screens. They are throwing a ray from that virtual point through the pixel onto the background behind. That ray is then being traced back to its origin. So the same tracing is happening but in the opposite sense. The beauty about this is when a ray is being traced through the pixel onto an object, and when that ray goes from that object to its source, let's say it encounters a leaf or a terrain, the varying intensity in that light ray can actually be used to create intensity variations in shadows and shines. The result of this is incredibly beautiful frames, you know, the things that we just talked about. With all this process that goes on in real time when it comes to applying these algorithms and these techniques and hardware support onto consumer grade hardware, what we will have it in our hands is really incredible graphics. This will be the next step, you understand? Now, NVIDIA is saying, as for this moment, is ray tracing is not an end-all be-all thing as per the scenario it is in right now. The current situation is not like the ray tracing that has come in our hands is the way it will be. It's actually like a stepping stone into higher incredible graphics in gaming applications. There are a lot of approximations that are going in the current scenario in which the ray tracing is being developed into the games. Although the things that are being produced by these approximations as per NVIDIA are better than what we'll receive from rasterization. So a thing that we can take is ray tracing is still new and there are not a lot of games that are providing ray tracing as of now. I know for a fact that Battlefield 5 supports it, although there has been a lot of optimizations that has been going on. So situation is pretty clear actually. Ray tracing for the time being in real-world applications such as games is not to look at as an end-all means. It's a stepping stone into something very beautiful. How much time will it require to achieve that state? It's not known at this point. How many games will support ray tracing and in what time frame? It's not clear at this point. So let's just hope we do not pay novelty for a feature in this graphics card that we may not be using for times to come. This was all when it comes to ray tracing. I hope you enjoyed this video, and if there's something you think I might have missed out, or if there's something that you think should have been mentioned and is not being mentioned, it will mean the world to me if you can just put all those things down in the comment section. I'll see you in the next one. Namaskaram.